Okay, well, guys, this is a bit how we do in this huge period of pandemic. So there is always something that you can do, I can do, we can all do. So yeah, we're gonna try a little bit, give a little bit of tutorial on robotic structures. So I'm gonna open the app. Yeah, so depend on your computer performance. Maybe my computer is not as good as yours. The reason why it's taking longer, the software is quite heavy, but yeah, definitely we're gonna get through it and start operating on the matter that we can. So okay, there we go. We have the interface. You could clearly see that there is no any recent project. It's completely free and completely new. So you can design anything, but in our case we're gonna be designing a normal beam, pin on both sides as quick as we can. Yeah, so we have this, the building design. So we're not designing any building here. This is the frame tree design. We're not designing any 3D frame here. We're not designing any shell as well. Yeah, but we have the RC element design. Definitely a beam is a part of RC element. So we're gonna go to new project and click on it. So yeah, guys, the interface is getting ready. So we have the interface. This is not really important for now. What we do to design a beam, first step is to go to, because a beam is an RC element. So first of all we go to RC element, then we go to new. On new you can see there is a beam, column, foundation, continuous footing and so on, but in our case our common interest is the beam. So you click on beam. So once we have the beam, we can't just define the beam without knowing what we actually designing. We need to define the properties of the beam. So I'm gonna try and drag this table down here. So what I'm gonna click, I'm gonna click on the square and then try to drag this down here. Alright, so I'm gonna try and define the property dimensions. The base, I'm gonna set it's 30 by 70, which is the height in my case, and then I'm gonna say applied. You can clearly see that we have 30 by 70 beam. Yeah, but you can just look at this and look at the units we're actually dealing with feet. That can be a little bit of complicated for us. So we're gonna go to tool, job preferences, then unit and format. We're gonna go to metric and then say yes. Metric, yes, okay. Then we're gonna go to dimension. You can clearly see that it's already in meters, but for the sake of confirming that is in meter, you click on meter again and then you say okay. Alright, then you can see everything changes. So we're gonna define our span length. So span length, span geometry, you go to span geometry to define the span length. We're gonna be dealing with the 7-meter beams, and we need to define the edge support. So in my case I'm gonna go with 0.5 on both sides, and then I'm gonna say apply. But you can see that here the dimension have been changed because we changed the units feet to meters. So you need to redefine again the properties, which we said earlier that it was 30 to 70. 30 by 70. Then you said okay, you close this. Oh sorry, just a bit of rushing, making mistakes, but yeah, we can clearly make it correct. Yeah. Then you said apply also. Then we have the beam. We have the 0.5 edges, then we have the 7-meter beam. Yeah. So you cannot design the beam clearly if you don't define the load. We don't know how much load is the beam. We don't know what is acting on the beam. We don't know the properties of the beam, concrete, steel bars, and so on. So we're gonna start by defining the load. So you're gonna write there on the right of your screen, just right here, this pattern, it says load definition. Then you click on it. So in our case, since it's a normal beam, we're gonna be dealing with a normal distributed load. So the nature of the loads in this case is already mentioned. It's dead load. So you go to dead load and you define the magnitude, the load. So we're gonna be dealing with 10 kilonewton, and then it's 10 kilonewton per meter. So over the length, 10 kilonewton is acting over the length. So that's why it's a normal it's a distributed load, with, as we do call it in the structure analysis, UDL, uniformly distributed load. Yeah. So you're gonna say add. So you add that load to the beam. Then you change the nature of the load. You say live load. Then you change the magnitude. Here we're gonna deal with 5 kilonewton per meter for the live load. Then you said okay, then you add the 5 kilonewton. So this is a normal beam. So we have its pin on both sides. We don't really have much to hide here, so you're gonna close this. So a beam, this is a reinforced concrete beam. We need to define the pattern, reinforcement pattern, and the property of the beam also. So we're gonna click on calculations option. So we have this first page. It's general, it's everything. You don't really need to worry about this. So you go to concrete. So look guys, we working in American system. I don't know, people are different. You can find it better. I say I don't find it better. So I'm gonna try and go to tool again. I'm gonna close this first. Go to tool again, job preferences. Then I'm gonna try and change the materials. Yeah, so I'm gonna rather like to work. I would like to work with the Canadian system. Yeah, so here I have my concrete grade and so on. Yeah, so I'm gonna say okay. Then go back to define my concrete property again. So I'm gonna go to concrete. You can see that this is a Canadian system. So I'm gonna define the grade. So I'm gonna go with 25 grade, which gives me 25 MPa. The self weight is normally 23 to 24 kilogram per meter cube, but this is 25. It's slightly different. And then if you wanna change the stone size to 19 millimeters, that's fine, but this is just for the purpose of learning something. Yeah, then it's okay. Then you go to transversal reinforcement. So you actually need to define the grade here, which is 40, and then having a 275 MPa of characteristic strength. Yeah, then we're gonna decide on what pattern to use, looking at the diameter of our stirrups. So we're gonna unselect everything and then choose what diameter we would like to be for it to be for our stirrups. So then I'm gonna go with 15.9, which is almost 16. Yeah, I'm gonna click on that. But remember guys, we clearly forgot to mention something on the longitudinal reinforcement. So we could see that we select grade 60, but we didn't select any of this. So we're gonna select again everything and then choose. I'd rather go with the 32mm bar diameter, so I'm gonna click on this one. So this is one we're gonna be dealing with, 32mm diameters. Then additional reinforcement, yeah, that can stay as it is. Then doesn't really matter. Yeah, then you said okay, so it's done. We're gonna decide, we're gonna try and define our reinforcement pattern, looking at the shape and so on. So for the bottom reinforcement, the number of layers, we need to determine the number of layers on the bottom of our reinforcement. In this case it's already 2, and then in my preference I'm gonna go with 2. And then define the top reinforcement. In this case it's 3, but in my case I would rather go with 1, so I will define that. And then we have the transverse reinforcement. So here we need to define the pattern of the beam. So some people would like this shape, other this one, but for me, as most of the project that I've been dealing with, I always use this one. So not always, but in the project that I've been facing, so I use this. Then I'm gonna pick this. You can pick anyone if you want. Yeah, depending on the project, definitely, and on the needs of the client and so on. So you know how to work in the real world. So I define this pattern, then okay. Then I'm gonna go to construction reinforcement. So the diameters and the shrinkage reinforcement, it's something that we could clearly select, but to 5 or automatic, because we're not really sure this. We rather like it to be calculated automatically. That will help us a lot and save much time. Then we click on auto. For the diameter here, we click auto also. So the shape, main, constructional, lap length, yeah, just said main, yeah, it's okay. So you have defined everything. You have your dimension, the base, the height, the loads defined, and everything. So yeah, what you need to do right now is just to perform some calculations. Why calculation? Because yeah, this is the beam that we designed. We need now result. So you go to calculation, number of elements 1. It can only be 1 of 1 because we only designed one beam. So you said calculate. So we're waiting for this to get done. Oh wow, there we have the result. We have the result. We can look at the beam. Yeah, if you look at the beam, we have the loads defined here. We have the dead load is 10 kilonewton per meters. We have the live load is 5 kilonewton per meter. Don't worry too much for the self weight, as this is automatically calculated by the robotic system structures, so you don't really need to worry about that. So this is about what the distribution of the load is. You can close this if you want. So this is the beam view. So an important aspect of the beam that we can look at is the beam diagrams. There we can easily name the bending moment diagram, the shear force diagram, and even it could clearly even show us the area of the reinforcement, the area that need to be reinforced. So we're gonna easily go to beam diagram, and then this you can look. This is the bending moment. This is a normally uniform distributed load. Definitely we expect the maximum moment to be right in the middle. Yeah, that's correct. And then if you go a little bit down here, you can look at the shear force diagram. So mathematically proven, structurally proven, whenever we have the maximum moment whenever the point where the maximum moment is, the shear force is 0, and then you could clearly see that there it's 0, and it's not showing any otherwise, it's clearly 0. So if you want to get it more interesting, you can see the reinforcements. So there is a lot of things that you can see, the cross area steel require, but here we're more interested in the require area of steel. So you're gonna just click on and then click apply. So if you go down here, this is the area that need to be reinforced. So yeah, this is the area that need to be reinforced. This is a bit of the beam, and then yeah, if you want to get it more interesting again, you can go to beam reinforcement. So beam reinforcement, we have the main bottom with grade 60, diameter 10, assembly top we have grade 10, and then transverse main we have 5. So 23, we have 2 bars, two bars of 10 diameters, and then we have transverse main, so we have 23 stirrups. So if you wanna look at the 3D of the beam, I'll advise you to clearly close this, and then there is the beam. So if you wanna look it into 3D, yeah, there is the beam. If you wanna count, you can see we have 2 bar top assembly and the 2 bar bottom. If you wanna count the number of stirrups, we have 1, 2, 3, 4, 5, 6, 7, 8, 23, I'm sure. So if you don't believe me, whenever you practice, just count by yourself. Alright. And then the last thing that I wanna show you guys is the beam knot. Yeah, so we have everything. So this shows the material properties. We use concrete grade 25, the unit weights, the different grade that we use for additional reinforcement, transverse reinforcement, and longitudinal reinforcement. Longitudinal reinforcement meaning the 2 bars at the top and the 2 bars at the bottom to actually form our beams. Yeah, so you can see the character strength is definitely different, which more makes sense. So then we have the geometry of the beam. We have 7.50 meaning that we're adding the extra edge that we put 0.5 at the edge. And then we have the calculation of combination here. We have the loads. We have the calculation result, reactions. We have even the reactions here. So yeah, you can look at the reactions. We have the support reactions. So support 1 definitely will take as much as support 2. If you look at the details, it's the same thing really. Yeah. And then we have the internal forces. We have the different shape of the diagrams. We have the required reinforcement area, bottom. Yeah, so we kind of forgot to define it, but it's in centimeter square. You can easily work it out in millimeter square if you want. Then we have the deflection, and then we have the material survey. So everything. Yeah, so the last thing that I want to show you, it's the work that you can actually submit as work design that you have done so far. Yeah, and then we always submit that in terms of drawings and the image of drawings. So you're gonna go just on the right again, and then click here, it says drawing. You just click on, then you can see everything is defined for you. Everything it's actually defined for you. So we have this, we have the grade, we have this, so we have everything as you can see on the drawing. And then we have the section of the beam. we have the grades, we have everything. I hope you guys are satisfied. This was a bit of what we busy with this period of pandemic. Hope to meet you soon in a next tutorial. We're gonna be dealing with trusses. We're gonna be dealing with frame in different